So if you want to build an effective decision tree, what you really want to do is you want to stop it before it becomes too specific to your training data. So how do you do it? There's a number of different ways to do it. The one simple way, which is not terribly effective, but you could basically stop splitting when the subsets become too small. And a formal way to the formal way to quantify it is you try to measure if a split is statistically significant or not, right? So if you have a set of 10 items, or if you have a set of 2 items and you split it into 2 subsets of size 1, and one is positive and the other is negative, that is not a statistically significant split, because you're guaranteed to improve performance, and it's a coin toss effectively that you're doing. But if you have a set of 100 items and you split it and you get 52 and you get a perfect positive of size 50 and a perfect negative of size 50, that would be significant because you have a lot of repetition. So that's a significance test. A better way to do it, though, is to use a validation subset for post-pruning the tree. So the way this works is you take your training set, so that's all of the examples that you have for training the tree, and you split it into 2 parts. You take a certain part of it and hide it from the algorithm. So that part is going to be called the validation set. You take what remains and you train a full decision tree on it, right? And we said that the decision tree will always split the training data perfectly. So you train a full tree, the one that gets 100% accuracy on the training portion. And then you do the following procedure. You pull out your validation set. You run your validation set through that tree, you get an accuracy. And that accuracy is not going to be 100% because your tree has overfit to the training portion of the data. So then what you do next is, let me actually draw what this looks like. You take your tree, you pick the nodes of the tree one by one, and then you say, well, what would happen if I removed the node entirely, right? So maybe I had a tree that looked like that. So maybe this was 10 positives and 10 negatives, and then maybe this was, let's see, 7 positives and 2 negatives, and here was, I'm guessing I would put 3 negatives and 3 positives, and then maybe here I've gotten perfect splits. So what you do is first you train this tree, and then what you're going to do is you're going to take a node one by one and cut everything below that node. So prune the entire subtree below this node. So you end up with just that subtree, right? Now you take your validation set, you run it through this pruned subtree, and you get another accuracy. So if this was node A, B, C, D, E, so I have the accuracy for everything, and maybe that was 0.7. Then I prune the node B, I have the accuracy with node B pruned, and maybe I get 0.75. Right? And then I try to do the same thing with node C. So I add this subtree back and take out the subtree that was under node C. So I have accuracy with the node C removed, and maybe that will give me, I don't know, 0.8. Okay? So after I've tried removing every possible subtree, I keep the tree that gave me the highest accuracy on the validation set, not on the training set. Because remember, doing it on the training set will always be worse, because the training set is optimized with a fully grown tree. But on the validation set, it's going to be one of these pruned subtrees that gives the highest accuracy. So you remove one subtree, and then you keep doing it again, and again, right? So I guess at this iteration, you would end up getting rid of this, and then at the next iteration, you might find that getting rid of A leads to an even higher accuracy. So removing both B and C
might give you 0.81.
So you keep doing that procedure for as long as the validation set accuracy keeps going up. And at some level you will start making your tree too small and your accuracy will start going down. So you stop at that point. Question?
So do you start from the leaves and sort of like try cutting the one leaf and then try cutting another leaf and see if it improves?
So the question is, do you start cutting the leaves one by one? Cutting off one leaf doesn't do anything. So you have to cut sort of the intermediate nodes.
Yeah, but starting from the bottom.
It doesn't matter, no. You actually iterate over all the intermediate nodes in the tree. It's an expensive process.
You iterate over all of them.
Yeah, yeah. But it's actually cheaper than building the tree. It's really pretty simple. Yeah. Question.
Do you check all combinations of trees?
Okay. Do you need to check all combinations if you cut the tree? That is intractable. No, you do it in a greedy way. So first you pick a subtree that gives you the maximum possible increase in accuracy on the validation set. You commit to that cut, and then you look for the next cut. So it's greedy. If you tried to do it optimally, you cannot. That's exponential in the number of nodes.